Welcome to this video where we'll show you how to change a POS project that originally comes from older versions such as POS 6.2 to a project that no longer just uses the classic POS objects, but takes advantage of the new optimization approach taken in Tegra Tools. This offers the potential of combining several of our products into one single optimization problem in a very flexible way. It requires you to use the Optimization tab and update your classic POS project to the new approach. And this video shows you how to do that in a few steps. We'll start with the classic POS project as shown here. Then, on the Optimization tab, define a new optimization manager, just like that. The first step is then to specify the settings of the optimization algorithm to use. We choose to use the min-max algorithm, which provides excellent performance for the problems with many variables, and we leave the default optimization settings. The next step is to specify some variables. And currently, the variables view here is empty. But if, for instance, we have a reflector with a spline surface, we can define what is called a bulk variable object for reflector shaping. And we can specify the reflector object where the spline surface is defined. Note that here we can choose to initialize the surface shaping if we specify an initial surface object. We'll choose this since our classic POS project already contained an initial surface object that can be reused here. Further, if your reflector surface has certain mechanical constraints that must be fulfilled, for example the minimal radius of curvature, then you could define it right here in the bulk variables object. In classic POS, these constraints would go into the reflector object, but in the new approach we have collected everything related to the optimization problem here on the Optimization tab. Then we choose to select the bulk variable, such that the possibly hundreds of spline variables on the reflector are included in the optimization with a few clicks. Note also that you could have multiple different bulk variable objects selected for optimization, or that you could choose here to add any real variable that you may have defined in your project, such that you could, in principle, optimize any quantitative given by a real number and the reflector shape at the same time. The next step is to define the optimization goals. In classic POS, this was always done through the so-called stations file, but here on the Optimization tab you have a much wider range of optimization goals to choose from. If we assume for now that I'm mostly interested in converting my classic POS optimization setup, then I'll go ahead and choose the Shaped Beam Stations file goal. I specify the PO object as the source that radiates the main beam, and I select the coordinate system where the stations are defined from my old project. Then I basically specify that the optimization goal is to be defined by my existing stations file that I've been used to work with, and that I could have created in SatSoft or another tool. The stations file's format is basically unchanged compared to previous POS versions. We choose to include this goal in the optimization, and note that you could continue here and combine the stations file goal with a range of other goals. For instance, we've added this multi-beam goal here to POS, which allows you to optimize directly for the C/I ratio of a multi-beam antenna right here in Tegra Tools. To finalize the optimization setup, we need to specify a user function that will be executed for each step of the optimization whenever the variables are changed, and we have to update the field on the stations. In classic POS, this was defined as a so-called optimization task, but here in Tegra Tools we can specify an entire command flow to be executed in each iteration. To do this, we first go to the Commands tab. We choose to define a new function. The one we have here is called currents, and we specify that we want to compute the reflector currents in each step by defining a getCurrents command using the feed as source. Note that we choose to leave the autoconvergence off in order to save time during the optimization, such that the pre-entered values in the PO object will be used to define the PO integration grid. Finally, we choose to evaluate the function we just created in each iteration of the optimization, and we then tell TICRA to add a getOptimum command to the main workflow. The getOptimum command was added here, and now, since we have successfully converted the project from the classic POS optimization to the new setup, we can delete the commands that we used in the old project. We are now all set and ready to launch the job. When the job finishes, the results will be presented here on the Results tab, just like the results for any other job. Note that the Optimization Manager has created some output types for us. For instance, we can see here in the optimization summary how much the residual is reduced during the optimization. Note also this nice feature for loading either the variables before the optimization or what you would normally need, loading the variables after the optimization into the current project. This is not done automatically, since you're allowed to continue working and make updates to your project while the optimization is running, which, if the optimization result was loaded automatically, could cause unexpected results. Since the variables are not loaded automatically, you can also queue multiple optimization jobs up and leave them running, and when you return, you can choose which one you like the most and then load it into the current project. If you're happy with the optimization results, you simply load the optimized variables into your project by clicking here. We get a warning that our spline file will be replaced by the optimum results, but we're happy with that, so we choose to proceed. If you regret later, you can always get back to the original file by loading the variables before the optimization. The project is now converted to the new flexible optimization setup in TICRA Tools, and you're basically ready to add more complex optimization setups here at the Optimization tab, which will allow you to take advantage of the many new goal types and of multiple TICRA Tools products in a single optimization job. Thank you for listening. I hope it gives you a good starting point for working with POS inside TICRA Tools.